Hello everybody, I'm Babak Saremi, market researcher and data analyst. Today I'm going to focus on non-parametric and attribute hypotheses testing using IBM SPSS and Microsoft Excel. Just note that the level of the contents is intermediate, so if you are not familiar with basic terms of statistics like histogram, p-value, or normal distribution, I suggest you to start with basic trainings first. There are some good sources on YouTube for free, and you can also find very good videos on lynda.com, which is LinkedIn Learning Now. Let's have a look at the differences between parametric and non-parametric tests again. Parametric tests assume statistical distribution in data, focusing on the normality of data, but non-parametric tests don't rely on distribution. Parametric ones should meet several validity in the data, but for non-parametric ones, validity is not the case. And data are continuous in parametric tests. However, they are discrete in non-parametric ones. And another important point is that the base for comparison in parametric tests is means, and for the non-parametric tests, it is medians. And the last point is that most parametric tests have equivalence tests in non-parametric ones. This is a big picture of non-parametric hypothesis tests. So if your data is not normal and you have just one sample, you can use either one sample sign test or one sample Wilcoxon test for comparing the medians. And if you have two or more samples, you have to do the test of equal variances, and for two samples you can run Mann-Whitney U-test, and for two or more samples you can run several median tests like Kruskal-Wallis, Moore's median test, and Friedman. Just note that the null hypothesis will again be rejected if p-value is lower than 0.05, and null hypothesis assumes equal medians or variances. There are 2 points to be considered in non-parametric hypothesis testing. First, although we focus on comparing medians in these tests, we can use Levene's test in One-way ANOVA, which is available in SPSS, to compare the variances of two or more samples. But the test is a little complicated because the data must be ranked first and then it should be aggregated. And finally, the deviation from aggregated mean ranks must be created. And the last point is that non-parametric tests are equivalent to tests in parametric ones based on the number of samples. So, for example, one sample t-test in parametric hypothesis testing will be equivalent to one sample sign test. If the comparison base is median and you have just one sample, and your goal is to compare the median of that sample to a specified amount, in SPSS you can use one sample Wilcoxon test, and the null hypothesis there X tilde is equal to m, in which m is a specified amount for the median. And for a two-tailed test, the hypothesis would be X tilde is unequal to m, and for one-tailed tests, it could be either X tilde is smaller than m or X tilde is greater than m. For focusing and finding out more about number of tails, I mean one-tailed and two-tailed, you can watch my video on parametric data analysis. If you have two samples and your goal is to compare the medians of those two samples, you can choose Mann-Whitney test in SPSS, and the null hypothesis is x tilde for the first sample equals to x tilde for the second sample. And if you assume x tilde for the first sample is not equal to x tilde for the second sample, it could be a two-tailed test. And the other alternative hypothesis could be x tilde is for the first sample is smaller or greater than the x tilde for the second sample. And for two or more samples, you have some options, including Kruskal-Wallis, Mode's median test, and Friedman. And for the null hypothesis there, you assume the medians of those samples to be equal. And if at least one median is different, then you can reject null hypothesis and keep alternative hypothesis. If the comparison base is variances and you have just one sample and you want to compare the variance of that sample to a target variance, then there is no any test in SPSS as it is not a very usual test. Also, you cannot find anything in Excel, but you can normalize your data and run the test for one sample variance for parametric data. And in this case, the null hypothesis could be the variance equals to S, and S is a specified amount for the variance. And as alternative hypotheses, we have variance is unequal to S for a two-tailed test, and variance is smaller or greater than S for one-tailed tests. And if you have two or more samples for testing the variance, you can use the Levene's test in One-way ANOVA in SPSS. But for null hypothesis and alternative hypotheses, we can focus on the aggregated mean ranks. So if there is no deviation from aggregated mean ranks, the null hypothesis will be kept. And if there is a deviation from aggregated mean ranks, then you have to reject null hypothesis and keep alternative hypothesis. Okay, to run the one sample sign test, we don't have any option in SPSS. However, you can do it using the Wilcoxon test. But assume that I'm going to do the one sample sign test for X6. So I have copied it to the first column of my Excel sheet. I can run it through the SPC for Excel, which is an add-in for the Microsoft Excel. Just go to Statistical Tools, Non-parametric, and you can choose one sample sign test. But I'm not going to do that. I just want to run it through the Excel itself. So first, I have to find the median. And for finding the median, I can use the median function and just select the first column data. And you can see that the median is 8. For recognizing the sign of the data, I easily can use the sign function. Sign, yeah. And just, for example, A2, which is 8.5 minus E. And just use the dollar sign to keep E2 unchanged. And this one. So this one is 1 or a plus 1. So this one is positive. And I just drag the formula to other cases, and you can see that there are some minus ones and there are also some zeros, which means 8 minus 8, and it's not minus, either plus. So for the number of positive signs, I can use the count if function, and the range now is the second column, which is the sign column. And the criteria, we can use the quotation mark, and because we are going to set the positive ones and count the positive signs, so I use equals to 1, which is the positive. And for the negative ones, we can use the same function, but just use -1 instead of +1. Oh, sorry. I think I just, yeah. And this one is -1. Yeah, now you can see that we have 48 positive and 49 negative values. So for count, you can just use the sum, or just you can use this function, E3 plus E4, which is the total amount. And for the minimum, you can use the minimum function, minimum of 48 and 49, which is 48. And just we want the p-value now. So I can choose the function of binominal distribution. So for the number s, I just choose the minimum and then comma. For the trials, I use this one, the count. For the probability, I'm going to test the half amount, which is 0.5, and just choose true here. Yeah. And yes, you can see that the p-value is 0.5. However, this one is for a one-tailed test. If you want to run the test for a two-tailed test, you just multiply formula by 2. And you can see that it's almost 1. And it could be a value lower than 1, but it shows it's 1. It cannot be greater than 1. It's a point. So for this one, it shows that the p-value is greater than 0.05. So the null hypothesis will be kept and it's not rejected, which means that the median of two groups are the same. And based on the 48 and 49, we can see that it could be true. And for the one-tailed test, Just delete these multiplied by 2, and you can see that it's 0.5, and it's still significant. To run the non-parametric tests in SPSS, for example, for one sample size, I will consider X6 again and go to Analyze, and then non-parametric tests and one sample. Here I choose automatically compare observed data to hypothesized, and here let me take these things back and then just select X6 and bring it to the test field, and we don't change anything else. I go to setting, and then you can see that we have some options here, but now I'm going to run the Wilcoxon sign test because I'm going to compare the median to a specified value. So if you remember from the Excel calculations, the median is 8, but let me test 9 for the hypothesis median and run. And now from the result, you can see that the significance level is 0.000, and decision is reject the null hypothesis, which means that the median of the sample, or X6, is not equal to 9. And if you double click on it, then you will have, this histogram from which you can see that the hypothetical median is 9, but observed median is 8. These are other statistics like standard error, standardized test statistic, and other things. And this is a two-sized or two-tailed test. For the, let me go down. For other tests, again, I can go to non-parametric tests, and now I'm going to compare two samples from X6. So I choose independent samples. I'm gonna test the equality of the medians for two samples from X6. So again, automatically compare distributions across groups. And then here I choose X6 as test field and region as groups. If you remember, region includes inside the United States and outside the United States, or inside the North America and outside the North America. So just go to setting, and now here from customize test, you can see that we have some options for two samples like Mann-Whitney, Kolmogorov-Smirnov, and Wolfowitz, but I'm gonna run the Mann-Whitney for two samples and then run. And again, you can see that null hypothesis is rejected, and the significance level is 0.00. And this is because the medians of two samples are not equal. And if you double click on this, then you can see the differences between outside North America and inside the United States and North America. And here the mean rank is 68.92. This one is 38.72. These are the mean ranks. And this is the Mann-Whitney test, and also we have other statistics here. Now, let me go out. let's assume that we want to compare the medians for 3 samples. So I again go to non-parametric tests, independent samples, and now I can choose Kruskal-Wallis, One-way ANOVA. But here, instead of 2 groups, I want something with, for example, 3 groups. And if you remember, we had 3 groups of customers. So just select this one, and I'm not changing anything else. Yeah, this one is the modes median test, and I will run this one too later. So just run, and again, the significance level is 0.000, and the null hypothesis is rejected, which means that at least one of the medians is different from the other groups. And just double click on it. Sorry. And here you can see the box plots, and you can see that although the median for this group and this group are almost the same, but this group is very different from the others. And this is why the null hypothesis is rejected. And now just run the test again, and instead of Kruskal-Wallis, I will test modes median test. Just run. And again, you can see that the null hypothesis is rejected. Let me double click on it, and you can see the similar results to the last test. Here you can see the grand median is 8, and other statistics, and the significance level, which is 0.000. To compare the variances of 2 or more groups, we have to follow 4 steps. First, we have to create the ranked data. So you should go to transform and then rank cases. And now I'm going to test the variances of 3 different groups of customers for product quality. So I choose the product quality as the variable, and just OK. And now when you go to your data set, you can see that something with an MRX6 is added, which is the ranked scores. And then for the second step, we have to create group means ranks. So you have to go to data, and then you have to go to aggregate. Now I choose the rank of X6, which is the new column, as the summary of variables. And because I'm gonna compare the quality, product quality, based on the customer type, I choose the customer type as break variables. And again, OK. I go back to my data set, and now another column is added with the name rx6 underscore mean, which is the group means rank. For the third step, we have to create the individual deviations from groups means ranks. So again, I go to transform and then compute variable. Here from functions and groups, I select all and absolute. And you can see the absolute amount here, but now I select rx6 mean. And we have to just set a name for the target variable. I will name it deviation, so DEV. And okay, again, let's go to the data set and you can see the new column with the name deviations, which is the individual deviations from groups, means, ranks. And for the last step, easily run the one-way ANOVA. So compare means from Analyst and then one-way ANOVA. But now I'm gonna check the one-way ANOVA for the new column, DEV. And for the factor, I choose customer time. And now you can see that the ANOVA test is significant, the F-test, and this one shows that at least one of the variances of three groups of customers is different from the variances of other groups. In attribute hypothesis testing, we consider proportions as the base for comparison. So the null hypothesis will be rejected if the p-value is smaller than 0.05 and it assumes equal proportions. So if we have one factor and we have just one sample, we use the one sample proportion test. And for two samples, we use the two sample proportion test. And if we have one sample with two or more samples, or if we have two factors, then we can use the chi-square test or the contingency table. Considering the proportions as the comparison base, if you have just one sample and you're going to test the proportion of that sample to check if it is, for example, 50% of the cases, then you can run the binominal test for one sample in SPSS. The null hypothesis would be theta equals to 0.5, and the alternative hypothesis could be theta is unequal to 0.5 for a two-tail test, and theta is smaller or greater than 0.5 for one-tail tests. If you have two sample sets and you're going to compare their proportions, in SPSS we have binominal tests for two samples. So the null hypothesis considers the proportions equal for the samples, and the alternative hypothesis could be theta for the first sample is unequal to theta for the second sample for the two-tail test, or theta for the first sample is smaller or greater than theta for the second sample in one-tail test. And if you have two or more samples or two factors, you can use chi-square test in SPSS, and you can see that null hypothesis here assumes that the proportions for all samples or all factors are the same, and it will be rejected if at least one proportion is different from the others. For comparing the proportions in SPSS, if you have just one sample or you have two samples and you want to compare the proportions to a specified value or between two groups, just go to Analyze, Non-parametric tests, and then here, Legacy Dialogues and Binominal. And I'm gonna test the region in which we had two groups inside the United States and outside the United States. So I'm gonna test the proportion to see if they're 50-50. I mean, 50 of the companies are inside and 50 are outside the United States. I don't change anything else, just okay. And here you can see that the significance level is 0.0 0.35 and it is smaller than 0.05. So we can keep the null hypothesis, which means that the proportions are almost equal. Here you can see that they are 61% to 39%. But this one means if we take more samples, then the result will get closer into a 50-50 case for outside North America and inside North America. And if we have, let me go now, if we have more than 3 groups, just go to Analyze and Non-parametric tests, legacy dialogues, and chi-square tests. Here I will choose another categorical variable with more than 2 groups. Let me test the customer type. We know that we have 3 customer types, so the proportions for them, for all of them, should be 33% or something like that to be seen as equal. So the expected values shows that all categories are seen equal. So I don't change anything else, just okay. And yes, here we have 2 tables. The first one shows that they're almost 33% for each group. And this is the chi-square test, the degree of freedom, and the significance level, which is really high. It's almost close to 1. So it's a 0.93, which means that the null hypothesis is kept. So it shows that the proportions are almost equal. From the next videos on data analysis, I will start topics on multivariate data analysis techniques using SPSS, Microsoft Excel, and AIMS. So let's get there and have a good one.